Welcome to C programming. In today's lecture, we are going to understand the arithmetic operators in C language. Arithmetic operators are as follows. I made a chart: operator, name, and description. The very basic operators: plus, minus, star, slash. That is for addition, subtraction, multiplication, and division. So as the name suggests, plus adds two values, minus subtracts one value from another. Star is used for multiplication, not the into sign. It multiplies two values. Slash is for division, divides one value with another. And percentage sign, it's modulus operator, that means it returns the remainder. And plus plus, it increments the value by 1. Minus minus, it decrements the value by 1. Let us see them in the action by making some simple programs. So I'm making a very simple program. First line is going to be hash include stdio.h, and then I'm going to start with the main, and I'm going to make it like this, void main, because I do not want to return any value from the main. I'm going to get some values from the user and compute the result, and int number 1, number 2, and result. So let us get two numbers from the user and perform the operations on those numbers. Enter first number. And how do you get the number? Input the number, that is with the help of percentage %d for integer variable. And number 1, int can store any integer number, whether positive or negative. It can also store the 0 also. Integers are, as we discussed earlier, are by default signed. Signed means they are able to store negative as well as positive numbers. Printf enter second number. Scanf percentage %d, comma, and number 2. This is you are going to input the number from the keyboard, and result is equal to number 1 plus number 2. Then we are going to print sum is percentage %d, comma, result. And when you run this program, it is a very simple program. Run code, and enter first number, enter second number, sum is 12. You can, okay, I will change the program slightly. I will copy the operators only, and minus, that is for subtraction, and after that into means multiply, so we'll write multiplication, and after that slash is for division. Okay, let us run this again. Enter any two numbers, like first is 20, second is 30, sum is 50, subtraction is -10, multiplication is 60, division is 0. All are coming on a single line, and subtraction is -10, multiplication is 60, division is 0. I will explain, but let me put them on individual lines by placing a \n in the printf. So \n means it will give a new line while printing, and let us run this again. Enter first number as 20, next as 30. 20 plus 30, sum is 50, subtraction is -10, because 20 minus 30, so we are getting -10. Multiplication is 600, division is 0. Now why 0? 20 upon 30, so it will be something like 0 point something something. And now what happens? Integer can store only integer value. It cannot store the part after the decimal, so that is discarded. 0, the integer part, is stored in integer variable result and displayed. And if I change it to float, then let us see what happens. Float percentage f, and while displaying also percentage f for all, So I will give the same numbers 20 and 30, and let us see them in action again. 20 and 30. Now sum is 0, subtraction is, and multiplication and division is computed properly up to 6 digits, as we discussed earlier, that the accuracy of float is up to 6 digits after the decimal. And if you want to print, let us say, only 2 digits, you need to format the result. Okay, it is percentage here, it will work, but it won't print the you can say it won't print the correct result, like it is printing the 0. So again we need to give percentage f, and let me clear the output. I will give the same numbers 20 and 30. So remember the format is foremost important. And now the sum is 50, subtraction is -10, multiplication and all the values are coming with 6 digits up after the decimal, and percentage d for integer, percentage f for float. And you want to have only 2 decimals, 0.2f, or 3 decimals, like that is your choice, but normally we use up to 2 decimals in our daily lives. So 0.2f. And when I run this again with the same values 20 and 30, 20, 30, you get the result up to 2 decimals. And because now the variables are of type float, so the result is in float format. So that was from the values getting from the user. Now let us make some fixed values, and I will start with the int first, and you can use the same operators. Result is equal to number 1 plus number 2, and we give some values to the number 1, number 2. I can initialize while declaring the variable itself. Number 1 is equal to 10, comma number 2 is equal to 5. And okay, if I need to print the result, I will use a printf. Result is percentage d, comma result. Now the values are fixed. Earlier we got the values from the user, but now the values are fixed. This particular line, these two variables are in. Okay, I can also initialize the result, initially 0. This is known as declaration and well as initialization. So we are declaring the variables as well as we are initializing them. Initializing means with an initial value. So if I run this program, result is 15. So you can try with the plus, minus, slash and star. Now the modulus operator. Modulus is used for remainder. I will write a comment. Modulus is for remainder. Okay, now let us run this program. And when the 10 is divided by 5, the remainder is 0. Let us change the number, make it say 11, and run it again. You get the remainder as 1. Okay, now it's very simple. And okay, one very interesting thing. Let us say I am going to divide. And now what happens? Result is 2. Actually, it should be, when we divide 11 with the help of 5, 2.5. But as I told you earlier, that integer cannot store the floating point, a part of the decimal, part after the decimal. That's why it stores only the integer part. And now, okay, let us see one more interesting fact. If I make it as float, now the number 1 is also float, number 2 is also float, and result is percentage f. And if I run it again with the same numbers, still you get 2.20000. Okay, not 2.5 earlier, it has to be 2.2. Now what happens, that the numbers are float, and float results in float division. So 11 upon 5 is 2.2. And okay, let's make one more change. I'm going to remove this. I'm going to have int I comma j comma result, and I is equal to 10 comma j is equal to, let us say, 3, and printf, no, let's first compute the result is equal to I slash j. Now I'm going to print the result with percentage f, so that should give us, I think, result is percentage f, as the float is for floating point, let us see, but it won't give you the result in floating point. It will give the result in integer format only, because we are going to make the result as float result. Okay, now you must be thinking that, okay, let me explain this program again. Two variables are integer I comma j, one variable is float result. I is 10, j is 3, result equal to I upon j. Now you must be thinking that as the result is being stored in float, the result should be float. It should be 3.33. Okay, I will clear the output and let us run the program and understand the logic behind this. Key result, why the result is not 3.33. The result is 3 point. Okay, by default, float will print 6 zeros after the decimal part, but the result is not on the expected lines 3.33. Now what happens? First, this expression is evaluated. Now what happens? I is integer, j is integer. Integer division is performed. That means the part after the decimal point 33 is discarded, 3 is stored in the result. So when we are displaying the result, that is being displayed on the screen 3 along with 6 zeros after the decimal. That is the default behavior of the float, to print 6 digits after the decimal. Now what happens that if any of the variable is float, either I or j, then the result will be in the float. But I do not want to change the original nature of I and j, that is the integer. But for the float division, one of the variables should be float. So I will do some very small change. I will do something like that, float. This is known as typecasting. So what is typecasting? Typecasting means that for the time being, for this particular expression, I am changing the value of I to float. Float, that means I will be treated for this particular expression as float. And if any of the variable is float division will be performed. Now you will get correct result, 3.33. That is with the typecasting. So they're very, very simple programs. So plus, minus, slash, star, and modulus, they are basically binary operators. Binary means they work on at least two operands. And let us say I have one more, k, and k is equal to, let us say, something like 12, and I will remove this, and I will make it all integer, comma result. Now what I'm going to do is that I have initialized three variables, and if I say something like this, result is equal to I plus j plus k. Now what happens? As I told you that plus, minus, slash, star, and modulus are binary operators. They work on two operands. Plus and minus and division and multiplication, they can also work on more than two operands. Plus here is an operator, j, k, and I are operands, but it can always work in a pair of two. Now what happens? I's value 10 is added to j's values, it becomes 13. 13 is again added to 12. So it works in pair. So the result will be 25 ultimately. It's float because we are printing it as wrong. It should be percentage d. Now the result will be 25. So you have to be clear about the format while you input the value as well as value output the value. Percentage D for int and percentage F for float. And if you are getting the wrong results, first check for the correct format, percentage D and percentage F and so on. So now they work on in pairs, and this is, I will write one simple line that is known as associativity. Is from left to right. Now what happens? We have used plus 2 times. So that means how to evaluate the expression. Because the operator is only plus, so it will be evaluated from left to right. So associativity is from left to right. Let me show you one more chart. Okay, I will cover these two in a while, plus plus and minus minus. This is rules of, say, arithmetic operators. Precedence. Precedence means priority. Operators within parentheses are evaluated first. So what are parentheses? They are round brackets. Unary operators have higher precedence than other arithmetic operators. They are evaluated first. I will give you an example. Multiplication, division, and modulus operators have higher precedence than addition and subtraction operators. That means if in any expression multiplication, division, and modulus operators appear, they are evaluated before addition and subtraction. And if operators have same precedence, they are evaluated from left to right. Associativity is from left to right for operators having same precedence. As we see, plus is having the same precedence, and even if I say something like that, minus, now plus and minus, they are having the same precedence. Same precedence means priority, so they will be evaluated from left to right. 10 will be added to 3, 13 minus 12, the result will be 1. Result is 1. You can change the order by enclosing them in parentheses. Now j minus k is in parentheses. It will be evaluated first. J minus k, 3 minus 12, 9. 9, but in minus. J minus k is equal to minus 3 minus 12 minus 9. And 10 is I, 10 minus 9. No doubt, we are again getting the same result. 1. Let me change the values. Let me change it to something like that. Let us say 1, and first without brackets and then with brackets. Result is 12. 10, 3, okay. And let me change something like that. I think because it won't make any difference in this particular case. So I need to make the value of because it's all plus and minus. Okay, let us try one more example. J equal to 12, and now what happens? 21, 22 minus 1, 21. And if I do something like that, okay, let me do one more thing like this. Now, okay, it plus and minus, okay, no doubt it is giving the same result. Let us check it with another example. Result is 20. Now what happens? Star is multiply. As we saw in the chart, multiplication, division, and modulus operators have higher precedence than addition and subtraction operators. So these operators, if they appear in an arithmetic expression, they are evaluated first, then addition and subtraction are evaluated. Now what happens? Plus, minus, and star, three operators, plus and minus are having the same precedence, but star is having more priority than or precedence than these two, plus and minus. So k is 1, 1 into 2, it will be evaluated first, 2. So I plus j, 22 minus 2, that will be 20. The result will be 20. And if you want to change the precedence, you can have them in the brackets. Now what happens? J and K, they are enclosed in parentheses. They will be evaluated first. So J minus K will be done first before star. Then the star will be done. Then the result will be added to I. Okay, J minus K, 12 minus 1, that is 11. 11 into 2, 22. 22 plus 10, 32. Now the result will be different. So you can change the order by enclosing the expression in the parentheses. And if, okay, one more example. Let us say I divided by j and multiplied by k. Now what happens? Slash and star, they are having the same precedence, like in the chart, multiplication, division, and modulus operators. They have higher precedence in than addition and subtraction operators. So they will be evaluated first. So multiplication and division, they are having the same precedence. Plus and minus, they are having the same precedence. But now the order of evaluation will be from left to right. So that is associativity is from left to right. So I will be divided with the j first. I is 10, 10 upon 12, 0 point something, but we are doing the integer division. It will be 0. 0 into k, 0. The result will be 0. Result is 0. So if an operator or more than one operator is having the same precedence or priority, the expression will be evaluated from left to right. So let us move on to our unary operators. Now one more thing, plus and minus, they can behave as unary operators also. But we need not give the plus sign, that is by default. But we can use it, no doubt. And minus can be used. So in this particular case, minus is behaving like a unary operator. No doubt result is same. It is useful sometimes, like I can say I is equal to 10 and j is equal to minus I. And if I print j, printf percentage d comma j, it will be the negative of I, minus 10. Or you can write something like that, j equal to I into minus 1. So minus as a unary operator is useful, but plus is by default. So we need not give the sign plus. Okay, and now I will remove the rest of the variables and I will keep only two variables, and let us check something. Okay, let me make another also, k, and I is equal to 10. Now what happens if I want to increment I by 1? I can say plus plus I. So it is a unary operator. Plus plus I means 10 will become 11. Printf percentage d comma I. Now what happens? I becomes 11, the value 11 will be printed. So unary plus plus means the value will be incremented by 1. 10 becomes 11. When this is known as pre-increment. If I give it afterwards, it is known as post-increment. Result will be same in this particular case because we are using it on a single operand. No doubt it has to be used on a single operand, but we are not using I in any other expression. Let me explain with one example. Similar is the case with minus I. The value will be 9. Or if I give it after this, then the value will also be 9. And now the difference, where does the difference come? Let us say I equal to 10 and j is equal to 1, and I say k is equal to plus I plus j. Now the behavior is different for plus I. This is pre-incrementing the I, then adding it the value of I to the expression. Now the what is the value of I? 10. Plus I means first increment. It becomes 11. Then it add it to j. 11 plus 1, 12. 12 will be stored in k. Okay. Let us check the result. 12. And what is the value of I? Okay, I will write value of k is and printf new line value of I is percentage d comma I. I will in any case will be incremented by 1. So the case 12, I was initially 10. It in any case is going to be 11, whether plus is before I or after I. Let me explain again. Plus I plus j. That means unary. Okay, let us see the chart again. Unary operators plus and minus have a higher precedence than other arithmetic operators. That means they are evaluated first. So first plus I will be done. 10 plus 1 11 plus 1 12. This will be 12. I is no doubt 11. Now if I give it afterwards plus, the effect will change. This is post increment. That means first use the value of I, that is 10. First use the value of I 10, add it to j, then store the value in k. So 10 plus 1, 11 will be stored in k. I no doubt is going to be 11. 11. Similar is the case with, so it makes a difference if we use it in an expression. Otherwise, if we are using it as a standalone operator, no difference. Similar is the case with minus. So first I will be decremented 9. 9 is added to value of j1. Result is 10. And value of I is going to be 9, no doubt. And minus. That means first use the value of I, that is 10. Add it to j. 10 plus 1, 11. Then decrement the I. 11 is the value of k. And the value of I is 9. So that concludes our basic arithmetic operators. So they are plus, minus, star and slash, addition, subtraction, multiplication, division, modulus for remainder, and plus for increment by 1, minus is decrement by 1, and operators, the golden rule within the parentheses are evaluated first. As we just saw that plus and minus, they have the higher precedence or priority than other arithmetic operators. Plus, minus, they are having the same. Multiplication, division and modulus operators, they are having the same precedence, but they are having the higher precedence than addition and subtraction. And if in any expression all the operators having the same precedence appear, like you are multiplying two number and within the expression you are dividing some, and within that expression you are taking the remainder of some operator, then they are evaluated from left to right. That is known as associativity. Associativity and precedence, there are two things to remember. Precedence means priority, which operator is evaluated first, and associativity is when the operators having the same precedence appear in an expression, they are evaluated in the order from left to right. Okay, that is our arithmetic operators. In the coming lectures, we are going to explore more operators. She provides us with many operators: arithmetic operators, assignment operators, comparison operators, logical operators, and bitwise operators. We just covered the arithmetic operators and their precedence. So stay tuned for the next video. Till then, goodbye.